Okay, so we're going to look at adding two matrices together, subtracting two matrices, and then multiplying matrices. So we're going to look at addition first. Okay, we're going to add these two matrices together. Okay, so before we add, we just need to make sure that these two matrices have the same dimensions. It's pretty easy to tell just by looking at these that they're both 2 by 2. But if it's not easy to just look and see, remember that the dimensions of a matrix are the number of rows by the number of columns. So the first matrix has 2 rows and 2 columns. The second matrix has 2 rows and 2 columns. So since these are the same size, we can add them. If they weren't the same size, we wouldn't be able to. So all you have to do to add these is to add the corresponding elements. So for example, corresponding elements would be this +2 and this -2 because they're in the same spot in each matrix. So in our answer, we're going to have 2 plus -2 in that spot. The next spot in this first row would be 3 plus 5. And in the second row, we have 4 plus 3 and 6 plus -1. Then we just add. 2 plus -2 is 0, 3 plus 5 is 8, 4 plus 3 is 7, and 6 plus -1 is 5. There's our answer.
When are those other columns things?
Last Friday, or like the Friday before Thanksgiving. But you can still turn them in. They'll just be zeros till I get them. Okay, let's look at subtracting. Okay, so again, we just need to make sure that these are the same size. Our first matrix has 2 rows and 3 columns. Second matrix has 2 rows and 3 columns. So since they're the same size, we can subtract. And we're going to do the same thing we did when we added. You just subtract the corresponding elements. So we're going to have 1 minus 6, 9 minus -2, and 5 minus 0 in the first row. In the second row, we have 2 minus 1, -4 minus 1, and 3 minus 8. Then we just subtract. 1 minus 6 is -5. 9 minus -2 is the same as 9 plus 2, which is 11. 5 minus 0 is 5. In the second row, 2 minus 1 is 1. -4 minus 1 is -5. And 3 minus 8 is also -5. Okay, now we're going to look at multiplying one matrix by a number. So we're going to do 2/3 times this matrix. This could be any number. It just happens to be 2/3. Any number times some matrix. So if you're multiplying a number times a matrix, all you have to do is distribute that number to all of the elements in the matrix. So we get 2/3 times 18, 2/3 times 24, 2/3 times 9, and 2/3 times 12. Once you guys get used to doing these operations, you can pretty much skip the middle step in all of these. If you can do that math in your head, it's not too bad. I just wanted to show you today so that you know, you have it in your notes what's actually going on. So then we just multiply. 2/3 of 18 is 12. 2/3 times 24 is 16. 2/3 times 9 is 6. And 2/3 times 12 is 8. Anybody have questions so far? Okay. Now we are going to look at matrix multiplication. Multiplying two matrices together. Okay, got a little bit of writing to do. Okay, I'll give you guys a second to copy this down. Okay, so we've got a matrix A, that's a 3x2 matrix. A matrix B is a 2x4 matrix, and it's asking, can the product A times B be calculated? And if so, what is the size of the product? So to add and subtract matrices, each matrix had to have the same dimensions as the other one. For multiplication, it's different. So in this order, A times B, A is a 3x2 matrix, and B is a 2x4 matrix. So you want to write it in the same order that it's given to you, A and B. And when they're written in the correct order, if the inside numbers are the same, then we can multiply. So these two numbers must match. And since those two numbers do match, they're both 2, the answer to the question, can the product A times B be calculated? That answer is yes. So then it asks, what is the size of the product? So the size of the product is given by these outside numbers. So the outside numbers give the dimensions of the product. So the dimensions of A times B will be a 3x4 matrix. Okay, so we know that we can do A times B. The next question is, can the product B times A be calculated? So the A and the B are switched now. So when we're checking, we have to write it in the order that it's given to us. So B is a 2x4 and A is 3x2. We write it in that order, and then we look at the inside numbers. So since those numbers don't match, we cannot multiply B times A. So normally, when you're multiplying, it doesn't matter what order you do it in. 2 times 4 is the same as 4 times 2. But when you're multiplying matrices, order does matter. You can't always switch it and multiply it the same way. Okay, so just in general, without actually assigning numbers to these matrices, if we have a matrix A with dimensions, rows times columns, matrix B has rows times columns. The number of columns in the first matrix has to match the number of rows in the second matrix.
Was it snowing out here earlier?
I didn't ever see it, but one of the maintenance guys said that it was barely.
It was sleeting yesterday.
I was outside when that happened.
Yeah, it was doing something.
Oh, they said that something's supposed to happen Thursday night. We'll see. I'm not getting my hopes up. I feel like it's too early. But I also feel like we didn't have any like gradual, like it didn't go from hot to cold gradually. It was just like you could wear shorts one day and then the next day it's freezing. So I don't know what that does to the weather. Maybe it'll be crazy this year.
What was it?
Is that what you're hoping for? Be fun. All right, we're gonna look at a couple examples. Okay, we're gonna try to multiply these two matrices. I'll give you all a second to copy them. Okay, so the first thing we need to do is look at the dimensions and make sure that we can actually multiply these two matrices. So our first matrix has 2 rows and 2 columns, so it's a 2 by 2 matrix. Second matrix has 2 rows and 4 columns, so it's a 2 by 4. So all we need is for these two middle numbers to match, and they do. So that basically just gives us the go-ahead to say we can actually multiply. Okay, so the way that we multiply these matrices, we use something that is called a product sum. So product is what you get when you multiply two things. The sum is what you get when you add two things. So we're going to use both of those as we multiply these matrices. Okay, so I know that my product is only going to have 2 rows. So I can go ahead and draw my bracket just around 2 rows. But it's going to have 4 columns. So our answer will be a 2 by 4 matrix. Okay. When we are asking what number is going to go in this first position in our answer, this position is the first row, first column of our product. So the way that we get this number is to use the first row and first columns of our 2 matrices. You guys can circle on your paper if you want, or if you just want to watch, that's fine too, just to keep it from being less messy. So first row, first column, we're using the first row of our first matrix and the first column of our second matrix. So you're always going to use the rows in the first matrix, and you're going to use the columns from the second matrix to get your answer. So using that first row and first column, we take the first 2 numbers from each, which are both 1. The first number in this row is 1. The first number in this column is 1. And we're going to multiply. 1 times 1. Then we're going to add the second 2 numbers being multiplied together. So the second number in this row is -3. The second number in this column is +3. So we've got -3 times 3. So we've got two products that are being added together. That's why it's called a product sum. Okay, so we'll do that math later. Let's look at, we're still going to be in the first row, but now we're going to be in the second position, so the second column. We're trying to figure out what goes here. Okay, so first row, second column means we're still using this first row, 1 and -3, but now we're using the second column of this matrix. And we're doing another product sum. So 1 times 0 plus -3 times 1. Everyone see where I got those numbers? 1 and 0, -3 and 1. Okay, now we're looking at this next spot. We want to know what goes here. Well, we're still in the first row, but now we're in the third column. So we're using this first row still, but now we're using the third column from our second matrix. And we do a product sum using those numbers. 1 times -1 plus -3 times 4. Okay, the last spot in this first row. So we're still in the first row, but now we're in the fourth column. So still using the first row, but now we're using the fourth column from our second matrix. So our product sum is 1 times 2 plus -3 times -1. Okay, so let's notice a pattern really quickly. Since we used this first row, the 1 and the -3 for every one of these, those numbers should match. 1 and -3, 1 and -3, 1 and -3, 1 and -3. That's how it's supposed to be since we used this first row for each one of these product sums. What changed were the second numbers in each product because we're using the different rows, or sorry, the different columns for those. So this should be 1 and 3 to match this column. This should be 0 and 1 to match this column, -1 and 4 to match this one, and 2 and -1 to match the last column. So I like to use those patterns to help me with the rest. Since I know the first number in each one of these products comes from this row, the first number in our second row is going to come from the second row of our first matrix, 7 and 2. So wherever there's a 1 and -3 in these product sums, now there needs to be a 7 and a 2. So I just write it right below. So I'm replacing the 1 and the -3 with a 7 and a 2 for each one of these. Okay, so the second number in these products come from the different columns. So these numbers should match whatever is right above it. Since this position is the second row, first column, we used the second row numbers. We've got 7 and 2, but we're going to use the first column, which is 1 and 3. So it should match whatever's right above it. The next numbers are going to match what's above it, which is 0 and 1. -1 and 4, and 2 and -1. So across the rows, your first numbers in your products should match. And the second numbers should match whatever's above. Then all that's left to do is to actually do this math. So I'm just going to do all the multiplication first, and then I'm going to go back and do the addition. So we've got 1 plus -9, 0 plus -3, -1 plus -12, and 2 plus 3 in the first row. Second row is 7 plus 6, 0 plus 2, -7 plus 8, and 14 plus -2. So now we'll just add and we'll be finished. 1 plus -9 is -8, -3, -13, and 5 in the first row. Second row is 13, 2, 1, 12. Questions? I know it's a lot of steps. There's no guessing though, or like you don't, I think that was the hardest part about solving systems of equations is just like even knowing where to start. This is a set, you will do it this way every time. So hopefully that makes it a little bit easier. Okay, I think I'll wait till next time to do another example before I give you guys practice problems. So we're gonna call it a day today. You guys on Zoom don't have questions, you are free to leave.